I'm Carly Cannell.
I'm Ramya Anand.
And Jalen Brown.
And I'm Benito Perez, and our group, the Audio Crafters, were assigned the pet project of creating a mechanical music maker. This is the engineering design cycle. In order to put together our final project, we thoroughly applied the engineering design cycle. This means we started by asking ourselves what exactly our goal is, and then we began to research the different types of musical machines that we could draw inspiration from in order to craft our. This led to us imagining what these features could look like together, and was followed by our planning phase consisting of 2D and 3D modeling. The next step was to create a prototype and test to see how well it performed, and from there we improved and optimized our design to finish. So to start, we identified the primary objective, which is to create a mechanical device that plays recognizable music. We then analyzed the specific constraints and requirements under this, which is that the device has to be at least half mechanically powered. It must play recognizable music within the duration that we were given, which is 10 seconds to a minute. Be able to fit within an imaginary 3-foot cube. Be creative, original, and be able to ensure good music quality.
Research and imagine. In the second step of the engineering design cycle, we conducted research to inform the design of our mechanical music maker. We examined existing mechanical music makers, primarily drawing inspiration from music boxes and phonographs. The team extensively studied the mechanisms of traditional music boxes, focusing on a wheel and comb mechanism that produces sound by striking metal bumps on a rotating cylinder. We also derived our crank mechanism from the music box to supplement our mechanical power. Additionally, we explored the pavilion component of phonographs, which is a large horn that stems from the box in order to better amplify sound. We also considered how we could possibly incorporate a way where we could get a mechanism to strike on tuned bars, similar to a xylophone, in order to produce a sound. After researching resonance and sound waves, we found that most music boxes are constructed of wood. This is because the box material has a significant impact on sound quality, so we contemplated using wood or concrete due to their low sound absorption rates. The dimensions and shape of the box are also crucial, as they influence resonance and sound magnitude. We also proposed a sliding feature to adjust the box's size for sound modulation. By thoroughly researching existing mechanical music makers and considering various design features, materials, and sound principles, we were well equipped to proceed with the planned phase of our project.
We began the creative process by drawing it on paper and talking out dimensions. Then we transferred the general model to a CAD software to where we modified some functions and dimensions. This was the initial model we had planned for the box. And this was the initial models we constructed for the horns.
Once we planned out all of the parts separately, we started to create. We started by taking the necessary dimensions of the plywood and cutting it into the pieces we needed. We used a saw to make the straight edged lines and glued the corners together because we couldn't use nails due to the thickness of the wood. We used metal hinges to make the opening to the top of the box and incorporating the sliding drawer component. We then put together the wheel, legs, and pins that we purchased and put them in the box. We then focused on the horns. These were 3D printed in the Makerspace lab, and we drilled holes in the sides of the box to attach them.
Our testing went pretty smoothly. The wheel and pins still worked properly after being placed in the box, and everything fit and moved as planned. The only issue we had was the sound of the strikes to produce desired recognizable sound. We modified and improved our design by adding weights to the legs that are supposed to strike the sound bars. The weights we used were actually pennies. This served us well because they were the right shape, texture, and weight. They were also cost efficient for our budget. We lastly added a paint job to the box inspired by the recognizable sound we chose, Twinkle Twinkle Little Star, to add an extra creative touch.
What we would have done different. If we could go back and change something, it would likely be the drawer and horns. More specifically, we would have thought to put the drawer a little lower so it has a more drastic change in the sound level, as we put it too high and didn't really make an audible difference. We also would have considered possibly plating the horns with a more resonant material and putting them in a more optimal spot to funnel the sound waves better. These changes likely would have increased our levels of amplification.
Advice for students in the future. Some advice for future freshmen doing PhET. Maintain good communication. Communication is very important to be able to get everyone on the same page, express their ideas fully, and get everyone to know their roles. Make and stick to deadlines. Fortunately, we took our deadline seriously, and that allowed us to stay on track with our project, and it prevented us from having to panic from possible unforeseen issues. Meet with your group frequently. Whether that is in class or in person elsewhere, meeting with your whole group makes a big difference. And if you can't meet, let your teammates know ahead of time to plan for it. And lastly, take full advantage of design tools on campus like 3D printing, because they make the process fairly easy for you to use. 3D printing and similar resources here allow you to be creative and customize your design in the way you imagine it. So use the workshops and labs around to optimize your design.
Thank you.